In this video, I'm going to go over the addition of traditional machine vision to detector training. So I'm going to name this detector secret caps. And then instead of selecting an existing object detector or classifier, I'm going to select one of the templates, parts present or not. This is going to be for a molding application where we're looking for parts in a tool and then parts dropped from a tool. So normally I would select a camera and that would put me into a live view. In this case I'm going to use images from a folder. And I have a folder already set up that contains 2 images for simulation purposes. And when I hit OK in this case, because we're running traditional machine vision, it's going to start up the traditional machine vision engine. So once it's started up, I'm presented with the image, whether it be an image that I snapped or an image from a folder. And in this case, I'm going to kind of pick the center area, and you'll notice that the objects are already defined, the selectable objects. I'm going to call this part, and then I can either just manually label these as usual, or I can do copy. So this is also a new labeling program, which is a little bit quicker, simplified as well. So I can hit D and copy these in this version. I could also go over to the label list and do duplicate, which will duplicate all of them that I select. And then move them into position. You notice I'm trying to really center in on the center of the parts, because we're going to be using basically contrast. So up to you how you want to go about doing this labeling process. Almost done, and then the subsequent image is going to be a lot quicker. Okay, so I've labeled all my images, or all my objects that I care about. So these are all parts in the mold. Go ahead, save, close, and it's going to present that same image for me to verify, change. If I want to change it, I can hit template. So I hit template, it goes back in, reloads that image so I can make modifications. Not going to make any modifications because that is correct. Now when I go to the next image, which is going to be the mold without parts in it, the images or the labels from before get copied over. So I can either go in and hit the template to modify the labels using the labeling program, or I've got this little state button here where I can just change the state of the objects. So in this case, if I say that these are no parts, then it will change the labels. Notice that these are images with a part in place. I'll go ahead and hit next. Go to the next one. These are empties, so I definitely want to set these as no part. And I see that a couple of these are out of center, but I'll get those on the final verification. So I'm done with the few images that I had in this folder. So at this point, the program verifies that we have all the labels. We have both parts and no part labels in our images before it's going to allow us to do training. So at this point, if I go ahead and hit train, it's going to present the images one more time so we can verify the position of the labels. Make sure that these are centered. These all look good. So verify that one. Go on to the next. Verify this one. Go on to the next. Verify this one. You really only need to do 2 parts, or the enough parts to represent all of the possible states, which in this case are part or no part. So I'm done there, so I go ahead and save. And then from there, it's going to ask me, are these expected? And in the case where we're doing a part, no part check, we want these to be expected. So we say expected. If we had reference items, we want to mark them as reference. If we had defect, we want to reference them as defect. So I'll go ahead and hit OK. And the labeling process completes by setting up all of the limits for each one of these cavities. Now if I were doing a single part, it would be much easier even, and I'll get into that a little bit in this video. Notice, as before, the training dialog comes up, just asking you to verify the name of the detector, and then enter your email address if you want a notification sent when the detector is finished training. So this part of it is actually going to train an AI-based detector, but using the templates allows us to instantly start to test using traditional machine vision. So next I'm going to show you the results. Okay, this time I'm going to get into the single molded part using the same process just so you can see the difference between them. So I'm calling this one the 2 millimeter molded part. And again, I'm going to do parts present template, and I'm going to use images from a folder. So I've got a couple of images in this folder of a part in place and missing a part. So startup of the traditional machine vision engine, straight into labeling, and on this part I'm going to do the area where I know it's always going to be there. There's no need to do the whole part. We're just looking for presence or not. We're going to call this part, of course. Save, close. Hit next to get on to the next image. This is no part, so I can just select the no part and I'll switch it over to the other state. Okay, now it senses that the 2 states have been fulfilled. So now we're ready to go ahead and do training. So we jump right into final verification. So that's part, that's good. Next one, no part, that's good. Go ahead and save, close. Both of these are expected. Go ahead and let it figure out its variables and start training. And then the process is done. And as usual, I would hit close to train a detector, but the traditional machine vision is all set up and ready to go for running production to verify part and no part. So now I'm going to just show this running in, against a set of images that were taken from production. So this is actually scrolling through images that we took for training the detectors in the first place. And you can see that they're being correctly categorized as part and no part. So you can see this process is quite quick, very easy to set up, and can be done by an operator. Also see that it has no problem even on the shiny ones, because when we did the labeling and training, it determined what the best thresholds are for each of these positions by position. Alright, so now I'm going to show the 2 millimeter molded part running. So I'm just going to do this step by step. Put it in continuous mode. Note that this entire process is running slow because we're in a simulation mode. So in production, this is going to run a lot faster. So this is just running through a set of images that we collected during production. Kind of see this is labeling the parts, showing the score value. It's an intensity score, and the step. So this can be scaled for 16 cavity, 32 cavity, single cavity mold, whatever. by just doing that labeling process. So I expect the setup time to be something along the lines of 15 minutes, and then the inspection time to be something like 3 seconds, especially if we lower the resolution on the camera from the 42 to the 10.